Welcome to the second part of the video about Vertex animations in Unreal Engine 5, and we also will be talking about our plugin, is Vertex Anim, that allows to create such animations directly in Unreal Editor. In the first part of the video, we've seen how to animate a mesh, static mesh as a whole, using the material, the world position offset, like this camera here on the left. And in this part, we will see how to animate the separate part of the mesh independently, which allows us to create some cool effects, like, for example, those effects that come from the Easy Vertex Anim demo level and demo project. To make things more fun, we will take this camera, which is already animated, and try to kind of reverse engineer it and see how it's made. So to remake this. And then we will use the plugin to recreate this animation from scratch. So we will take the Unreal camera from engine content and just animate it using the plugin. So let's get started. First of all, I will take this camera here and duplicate it. And then I will put our material from previous part, this one, on it. And this is the material that scales it. So we will check it out. So this material simply moves the vertices of the mesh towards the center of the mesh, towards the pivot of the mesh. So you can check the previous video, it's all explained here. So we take the zero of the mesh in the local space, transform that to camera relative world space, and then subtract the position of the vertex, which gives us like the line from the center of the mesh to the vertex, and then we slide the position of the vertex on this line, and then we give that like world position offset. So like I said, I explained that in detail in the previous part. So we will start by just replace the animation just by a simple material parameter, because it's easier for what's to come. And then now I can control the scale here in the material instance. So you can see it all works. It even works in the other direction. Here we add the bounds. You can check the previous part to see why. And now what's the difference between the two? Well, the difference is pretty obvious. Here all the vertices of the mesh are going towards or away from the mesh pivot point. And here you can see the separate parts of the mesh. Every part is going to their own pivot point, like this body of the mesh going to the center of the body, and all those rings on the front are going to the center of the ring. So how we can make it? Let's check our material. So here, this is the position of the vertex. This is the scale, and this is the center. So all the vertices are going here. And basically, what we want is to specify a different point for different parts of the mesh here. Let's start by transform this to a parameter and call it, I don't know, pivot. Okay. And what can we already do with that? So we have our pivot here. And let's say we put something in the z-axis. Wait. above. And then when we change our scale, you can see our mesh, it goes up. So here there is this funny optical illusion. It looks like mesh goes actually away from us. And I got like, that really catched me off guard. The first time when I did it, I really took, there is some bug in my material, but no, mesh is going up and becoming smaller. So all the, when we scale it, all the vertices of the mesh are going to this point 1 meter above. And if we scale it more, you see, kind of disappears. Okay, so that's part one. We see that we can change this pivot point as we can, as we want. So we are not like constrained by the mesh pivot point, by the zero. That we will call that object pivot, mesh pivot, object pivot. Then now what we are kind of trying to do is to like here, for each sub part of the mesh have to their own pivot. And if you think a little bit more, this is all executed for each vertex separately. So we need to specify a pivot point for each vertex, so to speak. And then if we can make this, we connect this here, and we have it. We have our animation, which is made for each part of the mesh independently, right? Now, what options do we have to give some information to each vertex independently? So we have different options. We can give, for example, we can use a vertex color. No? Vertex color, it's something that we have for each vertex independently. And it totally probably can be used, but there is a problem with vertex color that it's actually a color. So it's a 8-bit value between 0 and 1. And then there is 4 channels, but there is kind of not enough precision if we want to do like here we did directly did 100. So with those colors, there's only those 256 possible values per channel. So another thing we could do, we could write those positions into the UVs. UVs have more precision, but they're just 2 numbers per UV channel. So we would need 2 UV channels to make it. And then if you think if we want to encode something else, like for example here we encode also the order of the appearance of those pieces, or we can encode the parent, or we can encode the not only the location but also the rotation of the part, the axis of the pivot. Then we need even more UV channels, and then it's kind of starts to like be too much information. Plus, if you imagine if you have like a mesh with a lot of vertices, like for example a night mesh, then all those UV channels will be added and added, and then there will increase the size of the mesh a lot. Plus, I think for the nanite there's even a limitation. You cannot have that much UV channel. So the third approach, and the approach that we will use here, is to use a texture and an UV channel. So we'll have a special UV channel that will be the index into that texture, and we will have a data texture, so like high precision thing without compression, and we will just read for each vertex into this texture. We will read some data. So we will like how is here texture sample node, and then we will probably have a special UV channel, because UV channel 0 usually is used for the textures to show the pixels, to show the colors and stuff. Then some other UV channel, and then put it here, and yeah, and that should work. So let's do the reverse engineering now. Let's take this camera and check what textures it uses. And we can see there's two textures. Matinee cam this, which is the color of the camera, and this texture called T-pose. And if we check this texture, let's check it out. It's a tiny texture. I hope you can see it. 5 times 4, so 20 pixels. Format float RGB, compression HDR, RGB 16 bit per channel, noise RGB, no mipmaps, filtering nearest neighbor. So it's really like an array of numbers, like an array of vectors, 16-bit floats in which you can store like the coordinates. It's not like a color from 0 to 1. You can store like arbitrary number in the limit of the precision of 16-bit. So it's perfect for storing the coordinates of our pivots of our part of our mesh. Now let's study the UV layout of the UV channel 1 that is used to index the data texture with pivot information. And for this we will be using the UV editor included with Unreal. So that's our camera. Cool. That's the UV channel 0. We are looking at UV channel 1. And we will take our texture here, T-pose, and use it as a background. Yeah. So there it is. So one thing, as you can see, our texture is not square, 5 times 4, but for Unreal materials, all textures are square. So UV are already between 0 and 1. So it's stretched for us. And now if we take the vertices of the camera and select them all, we can see the layout, and we can see that each part of the mesh, it's mapped here in the middle of each pixel of this texture. These squares are actually pixels. And so if I select all those with, I see that represents the main body of the camera. So every vertex here in this body, it has exactly the same V coordinate, which is this number. And the color here cannot really represent the content of this pixel, because it's actually an arbitrary float, but this contains the coordinates of the center of this part. And if I check here, corresponds to this panel. So again, it contains the coordinates in the mesh space of this panel, and so on. This is this ring. That's the part, the viewfinder. So you see how it's done. So to recapitulate, for every vertex of our body, for example, the vertex shader will be run and will sample the texture at those coordinates that will return the position of the pivot corresponding to this part. And finally, why we store this as a square texture? Because, you know, we could just make a texture of 1 pixel high and just 20 pixel wide. And the reason is that it's for precision too. Imagine you have something like 256 by 256 texture. So the step here will be 1 divided by 256. Well, now if you unroll this texture like a line, it will be, the step here will be much smaller. And this will probably cause a precision problem. So that's the reason why we try to represent that like a rectangle to avoid those problems. Now that we've seen how it's all organized with UV channel and data texture, we can also imagine how we can extend this. So for example, here we also use RGB. So we can store something in the alpha channel, like for example here the order of the appearance of those pieces are stored in the alpha channel, or the parent here of those rings is stored in the alpha channel. We can also imagine to have more than one texture. So for example, in those examples, like here, the forward vector of the pivot around which those parts are rotating is stored in another texture. So there's 2 textures which are sampled in the same way. And so this technique with channel and data textures is called Pivot Painter 2, and it exists inside Unreal since a lot of time. And if you check the Unreal documentation, you will find it. And originally, it's to create those textures and those UVs, you need to use a script for 3D Studio Max. And what we are doing, our plugin, is basically the same thing, but it allows to do everything directly in the Unreal editor. And we will now show how to use it. We will take this camera non-animated directly from engine content, and we will create the UV channel and the texture, and we will recreate this effect directly here without leaving Unreal. Let's make our animated camera from scratch now. I will go here into engine and search for matinee cam, just here. It also its material. Copy this, turn back. I created a new folder, put that here. So far so good. So I put the camera here and I go to the modeling mode. And Easy Vertex Anim is a plugin for the modeling mode, and it's located here. And I will run the the plugin. So the plugin will, if it doesn't understand something, it will tell you. So here it says, this material has no material layers. And how we implemented it now is that we put all the animation stuff in a material layer, so it can be separate from the main material, and it's actually kind of easier to work with existing materials. If you have like some complicated materials, you don't need to put all this world position offset in there. You can just add a layer, and in the same way you can have a different kind of animation for the same mesh as layers. And in the future, we think also we probably will implement the other approaches. So there's the warning that it's looking for the material layers that are not supported. It will still work, but some things will not be working properly. And the second pop-up says that we need to do anything, we need to specify our UV channel to index the data texture. Okay, so we will just cancel it for now. We will take this material and add the layer support to it, which you will see it's pretty easy. So here we don't have layer support. We will make a material attributes node. Okay, so we will connect color, specular, and roughness like this. We will transform this into that, and we'll also turn it two-sided because you'll see. And then we will add this, and that's all we need to do. And so you can see we won't really putting here our world position offset stuff. We will put it into a separate asset that will be plugged into this material layers thing in the instance of this material. So we separate, if you want, the graphics and the world position offset. Okay, so that's good. Now I will take this new material and put it here on the camera. Now if I run the plugin again, there is only the pop-up for the UV channel, which is correct. Now we'll start by creating this UV channel. Here's also a red text saying set up the UV channel. So here we will take our UV channel 1. Create new UV channel, yes. Okay, and now we can already work. So as we can see, this camera comes like this. There is no part, there's just one big part, and we can see its pivot in the center. And what we want to do to split it in parts, so there will be body, there will be those rings, the viewfinder, etc. And there we have some operations you can use, and among those operations there is an operation called split mesh. And those operations, if you look, there is of two kinds, pivot and UV. So UV is the operations that change the special UV channel. There is split and merge, and for the pivots there's some others. So I will choose split mesh, and I will say run. And here the pop-up say that it will generate the polygroups from the connected triangles. And so this our plugin, it uses mesh polygroups for representing those parts. And basically it will take it will create the polygroups for all the parts that are disconnected from other parts, and which goes very well with this mesh because it's really made from separate meshes. And for some other meshes, you will probably need to go in the modeling mode tools that allows you to create polygroups in some other way. There are other things in attributes generate polygroups or paint polygroups. No, that what this pop-up is saying. So okay, and now our mesh is separated. You can see there is this part, there's the body. So I can change the pivot here, like if I change the pivot, I'm not happy, I can go here, reset it. And the pivot will be reset. I can hide stuff, etc. And then we need to specify the effect animation. And there's some number of predefined animation layers that comes with the plugin. Of course, you can also create your own, and they will be also shown here. And I will explain that more in detail in the next part of the video, but for now we just quickly go here and choose our scale thing. And now basically we have it. So I turned it two-sided to here have back sides of those panels visible simply. And then we have it. We have this timeline, we have this play button, we can visualize it. And now if I create accept, here we are. That's our texture, that's our material layer, and that's our material instance that links the material layer is the texture. So if I put this here, I have my animated camera. And the cool thing about the plugin that now I can just rerun it on the same on this mesh with this instance, and it will automatically recognize which animation layer we use it. So the scale in this case. And another thing is that we have here this anim layer. We can open it, and there it's very simple, really. It's more or less that the one we made. And here there is just one parameter, call it randomize. So we can change a little bit this effect. If I do play, and here I go and play, it does something else. So that's it for this second part of the tutorial. I hope you liked it. And in the next part, I will explain in detail different various features of our plugin and various other types of effects you can make with it. Thank you for watching, and see you in the next part.